Let's go over an example for this week's discussion quiz. In question 1, we're asked to use implicit differentiation to find the derivative of y with respect to x of this implicitly defined function. Feel free to use y prime in place of dy dx. So to do this, the step is to take the derivative with respect to x on both sides of the equation. In doing so, I want to be careful here that this is a product of two functions, so you want to use the product rule when you take the derivative of this, and also be careful that there's a chain rule situation happening with this y composed in place of the tangent function. So to start, I'm going to go through term by term, taking the derivative with respect to x. Starting with this 7x, the derivative of 7x with respect to x is simply 7. When you move on to the tangent function, the derivative of tangent is secant squared, and you leave the y on the inside alone. And by the chain rule, you want to multiply by the derivative of this thing with respect to x. That is exactly dy dx, and I'll write y prime. So this y prime is the derivative of y, and that came out by the chain rule. On the other side of the equal sign, we're going to take the derivative of xy cubed and then the derivative of 1. This is a product of two functions, meaning if you use the product rule, you start by taking the derivative of this first thing. The derivative of x is 1, I'll write that for emphasis, and then you multiply by y cubed. Product rule says you then add the first function left alone, times the derivative of the second function. The derivative of y cubed is 3y squared, and then you have to multiply by y prime, essentially by the chain rule. The 3 comes down front, you copy down the y, you subtract 1 from the exponent. Because this was not an x, it was a y, you have to multiply by its derivative. The derivative of 1 is 0, I'll put that for emphasis as well. If I simplify this line, I'll just write that this is 7 plus secant squared of y times y prime. That's equal to, I'll just call this next term y cubed plus, and I'll put 3xy squared y prime. My next step will be to isolate the y prime or dy dx term. I'm going to subtract this to the left, and I'm going to subtract this to the right side. And I'm going to do that in a single step. So what I'm doing is I'm subtracting 7 from both sides, but also I'm subtracting this minus 3xy squared y prime to both sides. And by doing this in a single step, everything on this side will have a y prime, and everything on this side will lack a y prime. So those cancel. I'm left with this minus that. So this is secant squared of y times y prime minus 3xy squared, also times y prime. That's equal to y cubed minus 7. The reason we put all of the y primes on one side is you can now factor it out from both terms. So you can factor out the y prime, and I'll do that as my next step. Factoring out the y prime leaves us with the secant squared of y, and then minus 3xy squared. And that is equal to y cubed minus 7. We can now divide this to the other side of the equation to state our final answer. And I'll put that work for it over here. Y prime is equal to this side, which is y cubed minus 7, all divided by what is in the parentheses here. I'm not going to include the parentheses because it's all going to be in the denominator. You can include it if you'd like, but I'll just simply write it is secant squared of y minus 3xy squared. And that is the final answer to this problem.